I see a path where eventually you will be serverless. And companies like ours are about looking at how do you compress that time of migrating from existing applications into the cloud, but also about looking for the design methodologies for developing new applications.
This is DevOps Paradox, episode number 65. Serverless Made Easy with Nimbella. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, Serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. We've been talking serverless for the past couple of weeks. And today, much like what we talked about on the previous episode, we said we were going to have a guest. Now, our guest today is Rodric Rabbah. He was a principal researcher at a 3-letter company, I'll say it, IBM, where he was the creator of Apache OpenWhisk, which, if you don't know what OpenWhisk is, it's an open source serverless platform. But right now, he's the co-founder and CTO of Nimbella. It's a serverless cloud provider. Rodric, thanks for joining us today.
Thank you for having me, Darren. Thank you, Victor.
We had a short chat before we started, and I think that what you're about to explain fits very well into what we are doing and what we didn't reveal yet to people. But anyways, can you give us your view of what serverless?
Yes. And I think to do that, I should look at how my journey into serverless began. And it started about 5 years ago. It was shortly after Amazon announced their new service called Lambda. At the time, I, along with a small team from IBM Research, we were working on something that was related. We hadn't realized that this ability to just push code into the cloud and run it, not thinking about infrastructure, not thinking about the server, not thinking about the runtime, was incredibly powerful. And we were doing that in a slightly different context, in the context of field programmable gate arrays. Not going to get into that too much because I think it would be a big distraction. But when we saw Lambda, it was an immediate light bulb for us. It was like, oh, this is incredibly powerful. And so we got together a small team and started building what became Apache OpenWhisk. And my team launched IBM Cloud Functions at the time. And over that period, what I got the benefit of working at IBM was to work with many of IBM's early adopters of serverless computing. And through that experience, I became convinced that the future of the cloud is serverless. And the reason I believe that is because serverless makes the cloud accessible. And it has a lot of properties that are desirable and that I think are necessary as we look into the future of the cloud era. So I've been saying this term of, in my view, serverless is inevitable. And that's when I decided to leave IBM and after a few months start a new company, Nimbella.
So what is serverless then?
So I think serverless is really a transformation, and it is a methodology that organizations have to adopt. And the reason it's a transformation and not any one particular technology is because it's a fundamental shift in the way you build and develop and deploy cloud applications. It's this emphasis less on infrastructure and underlying machinery that you use to build applications, and more on the value creation that organizations must deliver to their end users. And so serverless to me is really about developing at the speed of innovation.
I must say that I kind of like it, what you just said, because what I feel is that, because the first successful implementations or widely used implementation of serverless were related to functions, right? So now when people say serverless, they really mean functions, and when they say functions, they mean serverless. And I have that feeling that there is that some kind of misunderstanding of what serverless is, and I don't see it as being functions. Maybe functions can be a flavor of serverless, but functions being serverless, kind of putting that equal sign between the two, to me sounds a bit strange and maybe the wrong path that we're taking.
I agree. And in fact, when we talk about, my company, and in the conversations we've had with a lot of early adopters and just potential customers, that notion of functions as a service really was a distraction because I think it put the emphasis on the wrong part of serverless. And when you look at organizations that are still trying to figure out how to move into the cloud, and they're just learning about containers, they're learning about Kubernetes, and you say, forget all that, they're this alternative functions model, and you should just go to that. It's very disruptive, and it's a high cognitive load. And when I talk about serverless, I don't like to mention functions as a service at all. Because like you, I believe it's really just a building block in a larger context. A function by itself isn't an application. At Nimbella, we aren't a functions provider. We are a serverless cloud, as we say. And I think in some ways, sorry, go ahead. You had something to say there?
No, it's okay. Continue.
Yeah, and I think, the emphasis on functions really misses the boat because, as I was saying earlier, it's about the transformation. And if you're talking about moving into the cloud era, taking applications, you have to go through a path that has to be a gentle migration path, one that includes containers, one that includes a path where you re-architect the application. Because by the end, when you've adopted a serverless model, you've re-architected your architecture. You've re-architected the application. It is no longer the same application if you've done it right. And so that transformation has to have a broader view and not just a single-minded focus on functions as a service.
Actually, I would go even further, more radical view, is that I cannot imagine a serious company transforming significant workload, percentage of a workload into functions. To me, that simply sounds unrealistic. Yeah, I mean, I'm not saying that there is no place for functions, and I'm not even talking about serverless now, but kind of, developing something that is 50 lines of code. That simply sounds unrealistic to me, because then if I take a serious organization and say some kind of enterprise, and then I say, okay, let's transform zillions of lines of code into functions, that's simply not, I don't see it happening.
Absolutely. And if you look at some of the architectures that organizations that have gone through some of their serverless journey and they've published essentially their architecture, you look at it and, if these are on Amazon Lambda, the Lambda is a tiny part of the overall architecture. I think it serves a particular purpose, but applications in general have more components. There's the compute, which is what functions give you, but then there's the storage, there's the event architecture, there's the bus mechanisms for communicating between things, and there's many different components that wrap around just the compute. And I think, why it's not just functions is if you look at what a computer is, it's not just the core CPU, it's the memory around it, it's the interconnected buses between them, it's the memory hierarchy, it's the network. There's lots of things that make up a computer. And just like that, if you think of the cloud as a new supercomputer that just happens to be serverless because somebody else is managing it, then you have to look at the totality of what it offers, and it's not just functions.
So let me ask a question, because what if everybody thinks that Lambda is the right solution? Is there a use case that the Lambda-like things truly solves?
There are, and I think you have to also take that in context. So I think the use cases are largely around reactive events, and I like to think of Lambda and functions as a service as providing a actor-oriented programming model that's now living in the cloud and easily accessible. And you look at the use cases that functions have been used for, whether it's for offline processing and synchronizing data buckets across regions or across clouds, computing thumbnails, implementing REST APIs. There's a number of use cases for which Lambda is really well suited for. And the growth that it's had over 5 years is incredible. I think it's exponential growth. I remember at the first serverless conference 5 years ago where I met Dr. Tim Wagner, who's considered the inventor of Amazon Lambda. And I had asked him, how many Lambdas are you processing a day? And I remember the number. It was 2 billion Lambdas a day. And, last year, that number was over 2 trillion. And that's incredible 5x, an exponential growth over that period. But it's a tiny fraction of all the compute that's happening in the cloud, which is still happening over servers, EC2 instances, increasingly containers in Kubernetes. So there's a lot that Lambda hasn't actually been used for. And the place where innovation is happening today on figuring out what can you use this programming model for which it wasn't necessarily intended, is being done. I mean, there's lots of academic papers that are coming out on doing video processing, on doing rethinking how you actually build your Linux kernel, for example, that's using this power of the cloud with functions. And what it will lead to, in my view, and why I think it's a building block, is new abstractions and new models that lift and raise the model of computing, the programming model essentially, that's available to developers. So more and more functions play an important role in what the overall architecture becomes. But to build larger applications, you need to build new abstractions. And I'm not saying anything new in that move to increase abstraction and increase automation is ingrained in the history of our computing, where you start from mainframes to infrastructure as a service, platform as a service. And really, if you look at any aspect of computing, there's a vertical stack and we're increasingly moving up it.
Behind the scenes, right? The future of serverless is likely some form of containers and some form of scheduler that does all the good things for you in a way, right? Is that how you would see it, or?
I actually think it's more of a continuum, right? Where your code runs isn't necessarily all about containers. And I think there's a continuum of technologies that can be used depending on the context. And it ranges from containerless functions running in things like V8 isolates or similar technology, unikernels, containers, micro VMs, or maybe just proper containers, depending on the profile of the function. Do you know that it's actually stateless and well isolated? In which case, you can get much more compute density as a cloud provider by running it in a different context that isn't necessarily containers. But keeping with the serverless methodology, right, that shouldn't be an optimization that a developer makes. It's part of the optimizations and the runtime orchestration that the provider makes, right? So it's the Amazon that does that. It's Google, it's Azure, it's IBM, it's Nimbella. And that's actually what we do in Nimbella. In fact, I'll just call out one optimization, which is you can start with a function and we promote it to a container, actually making it more visible as a container under certain use cases where you need more sustained load. And it looks like its profile starts to look like more of a long-running microservice. But that's an optimization that happens completely independent of what the user's intent was. So that's my view. I think there's a lot of technologies of which we are on containers and very container-centric today. But if you look at technologies coming out from Cloudflare and Fastly, where it's edge computing, different performance profiles running in isolates, there is a continuum there. And for the right use cases, you want to use the right underlying technology.
So what's kind of the type of involvement that you would expect from, let's say, a developer, right? There is the obvious, here's my code, run it, right? But then I guess you need a bit more than that. Kind of, this is the type of application or something like that that would allow the provider to choose what is the right strategy, right?
Yes, I think the Holy Grail is really, a way to understand that is to look at what's happened in parallel programming or programming for distributed machines. Right? The Holy Grail of parallel programming is you take a program and a compiler partitions it and then runs it on, say, a multi-core system, creates all your threads, handles all your locking, etc. But that was incredibly hard to do. And we haven't solved that problem. What happened with serverless computing and what's happening with the availability and the commoditization, if you will, of functions as a service is that you now have a computer that is distributed by its very nature, and it's flipped the programming model around. It suggests that to take advantage of this cloud, you have to build small functions and run them in the cloud. But by virtue of doing that, there's a lot of optimizations and a lot of metrics that the vendor can collect about the execution of the application. So it just begs for machine learning, optimization analysis, and feedback-directed optimization to say, hey, there's correlation here between functions that are running together. Maybe I should fuse them and run them as a larger monolith, if you will. And it's easier to go from smaller functions into coarser applications than the other way around. And so I think it would be ideal if the developer didn't really get so involved in saying, here are the directives I want to provide for how you actually execute my code. We are not there today. And you see this in the different technologies that are available. If you run on Lambda today, if you want to run a stateful Lambda, you use their model that says run this with concurrency limited to 1, and that gives you sequential execution. If you're using technology that is more Kubernetes-based, like Knative or OpenFaaS, then you're providing sort of your minimum replicas, your maximum replicas, and that's a bit more cognitive load that the developer has to think about. Apache OpenWhisk, which is a technology I helped develop, is more like the Amazon Lambda model. You just run, and the scalability just happens for you. You don't think about specifying minimum or maximums. So it's going to be a delicate balance between how much the tools can take in as directives and knobs and what the programmer can actually wrap their head around to provide as input to the platform. But I think we're still in the very early days. This is like when the mainframe was invented and Fortran in the 1950s. I think there's incredible innovation happening in the industry. It's happening at a very fast pace. And the solutions that are coming over the next few years, I think will be incredibly transformative.
Listening to what you were just talking about, a couple of things stood out to me. One was, and especially the way that Nimbella is doing it, I, as a developer, could care less about how it runs.
Right.
It is just, here's my code, go take care of it. But you had also mentioned earlier on that the developer has to think differently when they're developing. What is that shift? What is that shift that a developer has to make? Because I could say, again, as somebody that's been working with Spring Boot for 20 plus years, almost, or Spring, I should say, Spring Framework, I really shouldn't take Spring into serverless. Now, we can argue that, but I'm just going to make a broad statement there. How does a developer have to change how they develop?
It's really about thinking of your application in terms of its logical blocks and what is its architecture. And if you think about your architecture, and you draw blocks on a whiteboard or on a piece of paper, you draw boxes and you draw edges between them. The boxes represent some notion of compute. The edges represent data flow or communication that has to happen between them. And I think if you push this to the extreme, this is essentially what a serverless architecture becomes. It's the consumption of APIs that exist in the cloud. It's surfacing new compute and new data services as APIs themselves. And then the application and the architecture essentially becomes a synthesis of the data flow over all those APIs. And this is my view of that shift that has to happen from existing application development, whether it's a monolith or functions as a service, towards a transformation in a serverless sense, where you're largely consuming APIs, and functions are APIs. I think there's a duality between functions and APIs. So it's really about that synthesis of data flow and composition over those APIs that really represents the application. And if you lay that down, in 2 dimensions, it's looking at an architecture. It's a data flow graph. And I think this is what's difficult to actually do for most developers, because you're not trained generally to think in that way. Our programming languages don't push us to think and develop in this way. But that has changed, right? The rise of functional programming as more mainstream has occurred, whether it's in languages like Scala and their adoption, or the introduction of various models in Go and Golang. That shift is happening. And so it's going to make it easier, I think, in terms of thinking about that kind of data flow and synthesizing applications as architectures that way.
Let's assume that's true and the developer understands what they need to do. Most of the time, at enterprise level, the developers are not making the decision what to build. It's coming through project management, it's coming through whatever. It almost seems like solving basically that reprogramming of business analysts and project managers is going to be tremendously harder than retooling the developer.
I agree. And I think this is why you also need a gentle migration strategy for organizations where they already have applications running. And even if they're committed to being cloud first and shifting and modernizing their stack, that can't happen overnight. It requires training. It requires an acceptance of essentially a commitment to this re-architecture. And it doesn't happen overnight. And so I see a path where eventually you will be serverless. And companies like ours are about looking at how do you compress that time of migrating from existing applications into the cloud, but also about looking for the design methodologies for developing new applications. You can't just look at existing applications, but there's new innovation that's happening. And so it's easier to do it for new applications. And that transformation has to be bought in from the top down and the bottom up. It's just like agile. You can't just say we're agile. You have to become agile, and it has to be indoctrinated and has to be part of the company culture. I think serverless is exactly the same way.
Is it in a way similar? So if I take Kubernetes as an example, right? You need to develop applications in a certain way to benefit from using Kubernetes, right? We probably all agree on that. But on the other hand, you can also have that kind of transition period where you throw into Kubernetes whatever you have. You're going to get 5% of the benefits, but those 5% are still tangible, right? Are we looking into something like that with serverless as well? Is it kind of to get the benefits, you need to do things a certain way, but you can benefit partly without, or really applications needs to be, is it a requirement for applications to be designed a certain way to be serverless?
Right. And what I'm saying is exactly what you just said. It must be part of the equation to have this gentle migration path. You're just not going to be able to take applications and transform them overnight. And some things you just might not be able to do. It's just impractical or prohibitively expensive. So you must be able to have a model where, Kubernetes raises the level of abstraction. You don't have to think about restart policies. You don't have to think about what happens if my application dies, how my persistent volume is managed, et cetera. There are things that are automated at the infrastructure level that free you up. And so that's, if you think of serverless as a continuum, maybe that's a little bit serverless. And it has to be, I think, when you're looking at adoption at enterprise, whether it's big or small, that have applications that they're running already, you just can't stop and say, let's re-architect everything. It's too expensive. So you have to provide a migration path. And I think that's why Kubernetes is so attractive. It's because it gives you part of that path and gets you into the cloud faster, right? I think the goal should be for all organizations to essentially just adopt cloud because of the benefits it offers, not just in terms of reshifting the investment that you're making within your organization, but because of the tangible benefits that developers eventually are able to extract from it. And that's why I think, in whatever capacity, serverless is inevitable. It has desirable properties, and it's happening. It's just a matter of how fast can we get there for the full transformations in some cases that might be necessary. And if you look at what Vanguard has put out in terms of how they're doing their digital transformation, they had exactly this problem to solve. And their first goal was, let's just get in the cloud. And so for that, they had to shift and lift, and Kubernetes and VMs played an important part of that before they were able to adopt Lambda.
So we're talking about, and most of the things that we've talked about, and most of the time you hear serverless, you think stateless. Now, Lambda just introduced EFS integration. Not sure how I feel. Actually, I know how I feel about that. It's not positive. But it's just because it's EFS. Right? EFS has performance problems in general. But the concept is fine, right? I mean, I get the concept, so it's not a big deal. And one of the things that Nimbella solves, if you will, is actually it goes beyond the functions and goes to full applications, and not only full applications, but stateful full applications. That seems impossible.
Right.
Why the heck did you want to try to solve that one? Because to me, that sounds like, okay, this should just run in Kubernetes. This should just be on VMs. Why are you trying to solve something that has good solutions today?
Right. So let me clarify. We haven't solved the problem completely. I think we're just scratching the surface in what we've done. And I think the value in what we're doing is twofold. One of them touches on sort of what Lambda or Amazon has announced with their Elastic file system support. To build applications, I started by saying applications aren't just functions. And interesting applications have state. And there's many forms of state. And you look at, the kinds of things that you would do in an application. There's things, if you're building an API and it has a front-end component and a web-end component, you need storage, but the kinds of storage that you need are different. So if it's an application that has a front-end UI, you upload those assets to an object store, and then you serve them from a CDN, a content delivery network. That's one form of storage. If you are handling session state or transient data, streaming properties, you might use a key value store. If you are handling files and your application needs to process images or PDFs, etc., you need an object store. And then there's databases and many different forms of databases. And then there's a file system. So we focused on a subset of these. With an Nimbella account, developers can build essentially a front-end and a back-end application that's stateful. And what that means is every Nimbella account, right out of the gate, you sign up within 60 seconds. You can build an application that allows you to upload assets to a CDN, be able to take advantage of an object store, and be able to take care of transient state and streaming data through a key value store. We are working on a similar kind of technology to EFS, where we have a file system abstraction that's backed by object store. And there are applications for which this makes sense. For example, if you're doing machine learning and you have a model that you've trained offline to be able to recognize and label images, loading that model could be very expensive. You store it in an object store, for example, and lots of examples today do that. And if every Lambda, and if you're using serverless with functions to do this, then every function has to load this model. That's an expensive operation. Because you're using serverless, you don't know where your functions run. You have no notion of locality. And that's where something like EFS actually comes in that now you can store it and share those across functions. This is an optimization we've been working on at Nimbella, where you can have thousands of functions running. They all share essentially this reference to the object store that has your model that you've pre-trained, but you don't have to load it repeatedly because the system has taken advantage of caching the file and mounting it inside every container that's running your function. And so it's a file system abstraction over object store. And you can say, in large parts what we're doing is we're storing data locality to compute. In serverless and in containers as a service, you don't have locality. You don't know where your functions are running. You don't know where your containers are running, but you need access to data. And so if you can co-locate the compute and the data close together, then you have sub-millisecond latency. You can take advantage of system level caching to help you reduce costs. And what it translates to is better application performance, new capabilities, lower costs. And there's value in doing that. And that's what we set out to do at Nimbella and what we've been able to do. And the way we're doing it is a combination of commoditizing the underlying clouds that we run on. We are running on Amazon. We are running on Google Cloud. And we're taking advantage of the services that they provide. We're not trying to recreate those services. But in some cases, we deploy a key value store that's unique to a particular tenant because their performance characteristics require it. And so functions and key value store, like Redis, for example, are co-located, very low access latency, and that gives you new capabilities that you could do. And if I get back to sort of what serverless promises, which is, freeing the developer from having to think about various things, if you just want the concept of a key value store, you should just be able to use it. Not think about where it's provisioned, how it's backed up. And that's part of what we're trying to do. It's provide this programming model backed by underlying cloud technology that allows us to sort of broaden the set of capabilities that not only functions could do, but serverless programming in general allows you to do. That's not to say you're going to take a database and build it in this way, right? There are fundamental technologies that are sort of just primitives that the platform has to provide. And then there are capabilities that you can't do at user level. You can't optimize, your cache and your compute because Amazon doesn't give you access. These are things that the underlying platform has to do, and that's what we are doing at Nimbella. Did I answer your question?
Yes. I have one more question. Right. So this is going to be a very pointed question, and you can choose not to answer it, and that's okay. If I sign up for a Nimbella account, I create my front end app, I create my back end app. If I understood correctly, I have no idea where that is running. I could figure it out based on IP address when I hit endpoints and stuff like that, but besides that, there's no way to know. And based on what you're saying, I should not care.
You should not care. I think if we can deliver on that, then we've succeeded. The underlying cloud is completely commoditized, it's democratized, and we've made the cloud accessible.
Theoretically, I as a developer, I wouldn't even necessarily need to know whether it's Amazon or Google or Azure, theoretically. I mean, not necessarily today, but I could even say run it wherever it makes the most sense.
Right. And today, if you create a Nimbella account, you'll be able to quickly tell where we're running. We're primarily running on top of Google Cloud. We are live in 2 clouds today, Amazon and GCP. For various reasons, we tend to favor GCP at this point. Largely, it's a cost optimization. But the cost optimization is precisely why, as an end user, you shouldn't care. There's lots of things you could do at the low level to figure out, should you run on this cloud or the other cloud, and take advantage of different arbitrage, spot instances, et cetera, for different workloads. It's not the kind of thing you want developers to worry about. That's what the system provider should offer to you. As an end developer, I deployed my application, whether it's a Jamstack application or a chatbot or a mobile application, and I just want it to run. I want it to be available. I want it to scale. I want my cost to be well bounded and defined so I can budget. And so how the underlying architecture is running, where it's running, how the data is backed up, et cetera. These are all the things we're aiming to essentially save developers from. And I think that's part of, what offering a serverless cloud and a serverless experience is all about.
So what is cloud? Just to clarify, Rodric, when you say cloud, what do you mean by cloud?
I mean the public clouds. I mean running on somebody else's machines as opposed to your own data center. I think if you've already moved to the cloud and you're running in a VPC, you're a step ahead. But there's lots of organizations that still believe in operating and running their data center, that have their own workstations. And I think part of the migration that needs to happen for the cloud era is moving a lot of that. The other could mean sort of looking at adopting more and more of the native services that exist in the cloud. But I think that's a digression and goes towards, portability and vendor lock-in, where Kubernetes really starts to offer some advantages.
My company will not go to cloud because fill in the blank.
Right.
We can't because we're regulated.
Right.
Okay. We know that's false, but we'll go there for a minute. So how can Nimbella help me there?
So Nimbella is built on open source technology. And we have actually had conversations with regulated industries for various reasons. There are different points in their cloud transformation. And what's resonated for them about our technology is that we can essentially replicate much of that experience with respect to the developer experience in their organizations on their infrastructure. And we can do it in 2 ways. One, if they've already adopted Kubernetes in-house, then we just extend their Kubernetes cluster essentially with that developer experience. It adds on top. Or if they're still on VMs, we can deploy Kubernetes for them and then lay out the Nimbella stack on top of it. And that's part of essentially that gentle migration strategy of modernizing the development stack for an organization on-prem. And it has to continue. I think it's more important for those use cases to deliver that gentle migration approach. Because if you haven't even adopted cloud, all of this is not just transformational, it just looks impossible. And part of what we've been trying to do is say, well, we can extend that experience for you onto your infrastructure. We can train you in how to operate it. And because we ourselves are a small company, we've built incredible automation so that the system is self-healing. You can operate it with a small team. And now you can free up, large parts of your infrastructure team to now go and become developers or innovators that add value to your organization. So there's a number of possibilities there with respect to Nimbella. And I think this is where, a lot of the interest in private cloud or in hybrid cloud really comes in, with OpenShift, Knative, et cetera, is really about doing some of that.
So basically, now this may be oversimplified, but it's basically if I'm on-prem with my approved version of Kubernetes, I'll throw that in there, at least one that's you've at least tested. It's basically nothing more than a Helm install. Is that it?
We don't use Helm. We use kubectl, and we built our own Nimbella administrator CLI for that. There's a number of reasons, technical reasons for why we didn't do that. And being able to address all the variabilities between different Kubernetes installs that we've had to do, dropping down and just using the underlying kubectl commands directly was necessary. So it's not as easy as a Helm install, but we do have a one-click install. You installed in Nimbella admin CLI. You point it at your Kubernetes cluster, and you just say deploy, and off it goes. It takes about 15 to 20 minutes, depending on various setups. And then you have the exact experience of a Nimbella cloud that we host available to you. So that's part of where we are on that on-prem strategy.
So if people wanted to find out more about Nimbella, what's the best way to find out?
Go to our website, nimbella.com. You can message me on Twitter at Rabbah. We've been putting out a number of blogs. I think we're just slowly really starting to talk about the platform very publicly. So there's a lot of content that'll be coming out over the next few months to show and showcase the value proposition of the platform. But our website is sort of the one place where you can sign up. You can register for our newsletter. We're on the second issue, which just went out yesterday. You can get an account, like I said, within 60 seconds. If you don't succeed deploying your first application within 60 seconds, I'll send you a hoodie that you can wear in the winter.
I wear hoodies year round.
So they're really nice hoodies because I wanted to wear one, so I designed really good ones.
Oh, there you go. Well, you're based in New York, so you actually have real winters.
We do. Yeah.
So you need a real hoodie.
Yeah. Maybe we can get T-shirts as well. I'm sure we have plenty of T-shirts we can send out.
Yeah. Hoodies are always better because you can always take them off, right? Or what is it? You can always put layers on, but you can't always take layers off.
That's right.
Where I come from, you take off your T-shirt without a problem.
Yeah. Okay, cool. Anything else that you'd like to sort of wrap up with today, Rodric?
No, this was really nice. Thank you for giving me the opportunity. The way I met Victor was I learned about the book that you both are writing. So I'll give you a shameless plug for your book. It's really good. And especially the serverless chapter that is a work in progress, but I've read the early parts. I think I'd recommend it to everyone. It's really good stuff.
Okay, so you're still here. And we're sort of wrapping, but you told us before we started recording that you disagreed with us on probably more than one thing, but what was the biggest thing you disagreed on?
The Kubernetes aspect. I think there's no K in serverless, and that goes for anything Kubernetes related. And what I mean by that is, I don't think developers should be exposed to Kubernetes in any way. That doesn't mean it invalidates what I just said, because I believe, as we discussed in the podcast about gentle migration, et cetera, and Kubernetes is a fundamental part of that. But what I think is important is really raising level of abstraction, so you don't even have to think about Kubernetes. And in the book and in a couple of your podcasts, it's a lot about Kubernetes, and I think if we're successful as an industry, right, that fades away. And I think that's really the part of what we should be striving for.
Yeah. So the part that I care about, to be honest, I do believe that Kubernetes will one day become transparent. It will disappear. Actually, it will not disappear, right? But it will just not be something we think about. Now, the reason why I care deeply about Kubernetes is that it is the best path forward that we have as industry to establish some form of a standard, right? So, for example, to me, Knative, I love Knative. And not necessarily because I want to run Knative myself, but because it has a possibility to be some kind of standard. What I'm really trying to say that I would like to see the world where I say, okay, this is my definition of serverless application, whatever it is, right? And then you and you and you compete. Who is going to give me better service and all those things? But I will not need to design my application for Lambda or for Azure this or for, right? So I'm looking for some kind of a standard that would become a common denominator, right? So that everybody competes in who's going to give me a better service, not who's going to force me to do things in certain ways so that it fits certain model.
Right. And I think that's going to be important. And I agree with that. I think the reason I don't view Knative as being able to succeed there is for Knative and the serving layer in particular is what I'm talking about, to be able to deliver the performance that's needed for short running functions, not long running or even medium running functions. They have to push some of that technology into Kubernetes itself. I don't think Kubernetes was designed to be able to churn through millions of containers or billions of containers a day. I think it's just not the right technology for it. And so Knative can't do that from the outside. It has to push in. And then within Knative itself, there are efforts to sort of look at, what do you come up with in terms of standardizing, at least on the function signature when you're talking about Knative serving for functions. What Kubernetes has done, in my view, is it's standardized the packaging and deployment model, right? You package a container, you deploy it, and now there's various things you can rely on. Where I see more the standardization that you're talking about being relevant is higher up the stack. It's something like the cloud event spec. It's here's how you consume and stitch together APIs. And I think we're still a bit far away from that before it happens. But when we succeed, you're right. I think Kubernetes fades into the background as well.
Yeah, I mean, just to clarify, I use Knative just as a first example. It came to my mind. It can be whatever, but that's why I'm much more inclined towards container as a service than function as a service model of serverless, simply because at least I have that common denominator. Maybe I will need to do extra things, but my common denominator today is a container image. Kind of that's some kind of a standard. Okay, I will need to write some JSON, YAML, whatever, depending on the provider, but at least we agree that container might be, or not, right? It might change. But I like that idea that there is a certain, I'm very fearful of any type of locking, kind of like.
I think it's more than just the locking, right? There's important things that, packaging as a container does for you. You know that when your code is packaged in the container, it will run the same on your machine and in the cloud. You can't do that when you're packaging things into zip file, right? You have to be ABI compatible. You have to write the right dependencies that, the cloud provider's runtime is giving for you. So it's more than just, it's fundamentally more in my view. There's also the other aspect, which is debuggability, right? If you have a container, you can attach, your debugger to it and you can step through your code. When you're running as functions, debuggability is impossible and you're back to, printf being your way of debugging. And there's innovation happening there, but there's a lot of tooling that has to happen that's more mature when you're talking about containers than when you're talking about functions. And in the end, if you just focus on just a packaging format, I think it's still too low level, right? You need to keep pushing up the stack, but I think you agree with that as well.
Yeah. It is definitely too low level. I'm just referring the other day I was trying to imagine what is the highest possible common denominator today, and that's a container. It's not high enough. I do believe it's not high enough but it's what we have today in a way. And honestly, if somebody would convert my container image into a VM tomorrow to run because that's better, I don't really care anymore. I'm giving you an image, right? That's what I'm giving you. It's your problem how you run it.
And what's happening with Knative, we've also built our own service on Nimbella build service, is that if you are starting with functions and you just want to reduce the user's code to just their code, you have to be able to take that code and build it remotely for them. So you have to offer build as a service. And so that's part of the tooling that has to come up and mature for the cloud vendors to be able to change the packaging format from containers to something else that can become a standard, and then specify what are all the restrictions, etc. It just becomes harder. Container, in some ways, solves that problem. I really like what Google did with Cloud Run, right? Because it's kind of like the functions experience where your container starts and stops. You have per activation tracking, essentially, but it's a container which is nice and easy for people to get their head around with respect to packaging and what you have to do. So I like that model quite a bit. And that's more of container as a service, if you will, as opposed to functions as a service.
Okay, let's stop there because we could go for another hour talking about those kinds of things. But I did want you to have your say of why you disagreed with us. But in the end, I think we're more in agreement than we are in disagreement. You're future looking, we're 12 months looking.
Mm-hmm.
Right. So that's what I'm saying is I think further out, we're both in agreement that, yeah, we shouldn't care about Kubernetes in 5 years. We shouldn't care about how it's packaged. What I care is, here's my code, go run it.
Right. Right. On that note, I agree. Yep.
Okay, cool. Thanks for hanging out today, Rodric. Talk to you again.
Yeah, thanks for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.